the various steps in what drawing Lewis structure. So I'm going to take each of them one by one. And I'm taking each of the steps. I'm going to explain them to you. Do you understand? So now, step number one. Step number one. Now, the first step in what drawing Lewis structure is what calculate the total valence electron. Idea calculate what the total what valence electron. And how do you calculate the total valence electron? If you're looking at what by some the valence electron of each of the atom in the what molecule. Idea. Now, at times the molecule can be a neutral, can be what an ion. Idea. Now, if it's an ion, there can either be a positive charge or what a negative charge. So, if the atom or if the compound is what is a positive charge. Now, when you're calculating the total valence electron, you must subtract the numbers of ions from the total valence electron. Do you understand? So if it's what is a positive charge, only you must subtract the total ion for the total valence electron. Do you understand? Now, if it's what an ion, if it's what a negative charge, if it's what negative charge, that is, if the ion is a negative charge, they want to what add what the total ion to the valence electron. So now let me explain to you. If for example here we have, for example now you calculate the total valence electron for what? H2O, CO2, CO3, 2 minus. So now let's start with this one here. Now let's calculate the total valence electron of what? This one, right? So here we have. Now remember, hydrogen is what is in group 1. Hydrogen is what is group 1. So how do you you never do what? 1 times 2 plus oxygen is what is in group 6, right? 6 times 1. How do I get here? Yeah. Hydrogen is in group 1. How many numbers of hydrogen do I have here? 2. 1 times 2, right? Plus. Now oxygen is what is group 6. That is the valence electron is what is 6 times 1. So you're going to be what? 2 plus 8. You're going to be what? 2 plus 6. You're going to be what? 8 valence what electron. 8 what valence electron. Here we have what? Carbon. Carbon, what group is carbon? Carbon is what is what? Group 4. So it would be 4 times 1, right? Plus oxygen is what is 6. 6 times 2. So it's going to be what? 4 plus 12, which is going to be what? 16 valence what electron. So let's go again. Okay, 4 times 1 plus 6 times 2, 4 plus 12, we're going to be what? 16 what valence electron. So the total valence electron here of CO2 is what? Is 16. Do you understand? Now let's put this on that one here. Here we have 2 minus, right? So it would be 4 times 1 plus. Here we have what? 6 times 3 plus. Now remember, this one is total charge, right? You add it, which one plus 2. Can you see that? So it will be 4 plus 6 times 3 is what? Is 18 plus 2 will give what? 24 valence of electron. Do you understand? So you can see how easy it is to work to calculate valence electron. So I will give you a try. I will give you the rest of the try. Try for here. SO2 SO3 2 minus NO3 minus PO4 2 minus. Go ahead, calculate the total valence electron for me in all this one here. What is the total valence electron of CO2? What is the total valence electron of SO3 2 minus? What is the total valence electron of what? NO3 minus. What is the total valence electron of what? PO4 3 minus. Yes, 3 minus. So go ahead and try this one for me. Leave it at the comment section. Just understand? So that's going to be what my first step. Right there. My first step. Now I'm going to do what my second step. 2. Now what is step 2? Step 2 is what? Is to draw. Is to what? Draw the what? The skeleton of the molecule. Draw the skeleton of the what? Molecule. Draw the skeleton of the molecule. Now by placing the least electronegative element at the center what atom, why the other would not be what? The side atom. Then connect the side atom to the center atom with what? With a single bond. Right there. Now, but what you want to understand here is that there are 2 elements that they can never be what? The center atom. Number 1 is what? Hydrogen. Hydrogen can never be a center atom. So whenever you are drawing this structure, never put hydrogen as a center atom. Why? Because hydrogen can only form a single bond because they want to obtain what? The duplet electron. Right there. So that is why hydrogen will always be what? a side atom. Hydrogen can never be what? The center atom. Do you understand? The next element I want to look at is what? That can never be a center atom. That is, when you are drawing Lewis structure, don't make this mistake by placing this element as a center atom. The next one is what? Is fluorine. Fluorine can never be a center atom. So when writing electrical configuration, never place fluorine as the center atom, and there's a reason for that. Why? Now, because fluorine is what is the highest electronegative element in the periodic table. So the highest electronegative element in the periodic table is what? Is fluorine. So that is why fluorine can never be what is center what atom. Do you understand? So remember, when you are drawing the skeleton here, the first thing you want to know is that is to place the least electronegative element at the center atom. Why the other one will not be what? The side atom. Do you understand? So now let's give a practical illustration. Do you get that? Let's give a practical illustration so you understand. So now you want to look at what? H2O, CO2, CO3, 2 minus. I want to look at SO4, 2 minus. Right there. So you want to draw this. You want to draw the skeleton of all these ones here. Very important. I want to draw the skeleton. So remember, let's therefore calculate the valence electron. Valence electron of what? Of H2O is what? Is what? 1 times 2 plus what? 16 times 6 times 1. Right? We're going to give you 8 valence electron. Right? 8 what? Valence what? Electron. So therefore, step by step is to calculate the valence electron. Right? So in the sense that the valence electron is 8. Now let's draw the skeleton here. Hydrogen can never be a side atom. So hydrogen can never be a star atom. So here we have hydrogen and oxygen. Therefore, oxygen will not be what? A center atom. Do you understand? So it will be what? Oxygen as a center atom here. Then hydrogen, the two hydrogen will not be what? A side atom, right? So when you have done that here, you connect what? The side atom to the center atom with a single bond here. Right there. With a single bond. Understand that a bond contains 2 electrons. Do you understand? A bond contains an electron, 2 electrons. So when you join it on here, by connecting what? The 2 hydrogens to what? To the center atom with a single bond here. Oxygen now have 2 bonds, right? Remember, 1 bond contains 2 electrons, right? So it means that I have used what? Out of the 8 electrons for the total valence electron here, I have used what? 4 electrons right there, because here I have 2 bonds here. So I'm not saying what? Remaining electrons. So I have to calculate what? Remaining what? Electron. My remaining electron is going to be what? My remaining electron is going to be what? 8 minus 4. Now, how do I get the 8? It's for the total valence electron. How do I get the 4? It's from the bond. Right there. The 2 hydrogen connected to oxygen with what? With a single bond. This one contains 2 electrons, or contains 2 electrons, make what? 4. So the number of electrons I have not used is going to be what? 4. So my remaining electron is what? Is 4. Do you understand? So this is called the skeleton here. Now let me look for what? CO2. CO2. Now what is valence electron? Now what is valence electron? Going to be what? 4 times 1 plus what? 6 times 2, right? So it will be 4 plus 2. We're going to give me what? 18. We're going to give me what? 16 valence electron. 16 valence what? Electron. Right there. So the next to do now is to what? Draw the skeleton. Right there. Now to draw the skeleton here, carbon will be the center atom. The 2 oxygen will be the side atom. Do you understand? So it's going to be carbon here connected to 2 oxygen. Just connected to 2 oxygen here. If you check it very well here, for that I have 2 bonds, right? My 2 bonds is having electron. My 2 bonds is having electron. My 2 bonds is having electron. 4 electrons. Even out of the 60 electrons, I have used what? I have used 4 electrons. So it's going to be remaining electron. Remaining what? Electrons. My remaining electrons here are going to be what? 16 minus what? 4. We're going to be what? 12 right there. We're going to give what? 12. Yeah, it's going to be what? 12. So after drawing the skeleton here, the number of electrons I have left is what? Is 12. Do you understand? So we are seeing what? Step 2. So here we have what? CO3 2 minus, right? Now let's draw the skeleton of this guy here. My valence electron here, my valence electron is what? Is what? 4 times 1 plus what? 6 times 3 plus 2, right? We're going to give me what? We're going to give me what? 4 plus 18 plus 2, we're going to give me what? 20 what? 4. Right there. So my valence electron of for CO3 is what? Is 24. Now let me divide the skeleton here. Here, this compound contain 1 carbon, 3 oxygen. So the carbon will be the what? The center atom, right? So going to be carbon here connected to what? 3 what? Oxygen. Do you see that? Connected to what? 3 what? Oxygen. 1, 2, 3 here, right? Now this can also be at the time. You can also write like this. It's still the same to just but I prefer to what? Place it up. I prefer to want to place it up, right? So how do I get what my remaining electron? Remember, they have 3 bonds, right? 1 bond contains 2 electrons. So if I'm going to have if I'm having 3 bonds here, then how many electrons is that? I'm having what? 6 electrons. It means that out of what? The 24 electrons, I have used what? 6 electrons. So I'm not going to have what? Remaining what? Electron. Remaining what? Electron. My remaining electron is what? Is 24 minus what? 6, right? 18. Can you see that? So you can see this is what the simple step how you can work else here. But I want to master step 2 here. So give the what? The give this one here SO3 2 minus NO3 minus PO4 3 what? Minus. So draw the skeleton here. Draw the skeleton here. Go ahead and draw what? The skeleton here. So that was going to be what? Step 2. Now afterwards, step 3 and what? Step 4. Step 3 and step 4 will go together. This way, we now start applying MT here to draw the perfect what? Lewis what? Structure. So let's move towards step 3. So I move towards step 3 and what? Step 4. Step 3 and step 4 goes together, which I want to find out what step when it comes to what? Drawing of what? Lewis structure. Step 3 is to what? Now remember, step 2 is to what? To draw the skeleton, right? Now step 3. Now remember, step 2 is to what? Step 2 is to do what? Draw the skeleton, right? After drawing the skeleton, you have to what? Get what? The remaining what? Electron, the electron that is left, right? Now step 3 is to what? Is to ensure that the side atom have the octet electron. So the step 3 now is to what? Ensure that the side atom have their what? Their octet electrons by giving them by giving them what? The numbers of electrons that can make them to be the octet electron before moving to what? To the center what? Atom. You understand? That will go to be what? Step 3. Then step 4 is step 4 is that if the center atom do not have the octets, if the center atom do not have the octets, move a substrate non-bonding electron from the side atom to form a multiple bonds with what? With the center atom to ensure that the center atom have their what? Octet electron. Now, which I'm going to explain to you now. Please just pay close attention here. Right there, just pay close attention. So let's start with the water. Let's start with water. Let's start with water here. H2O. Right there, H2O. Now, my valence electron is what? Is 1 times 2 plus what? 6 times what? 1. We're going to do 8, right? 8 valence what? Electron. There was step 1. Step 2 now is what? Is to draw the what? Skeleton here. To draw the skeleton here, oxygen will be what? The center atom. The 2 hydrogen will be the what? Side atom, right? So it will be oxygen here connected to what? 2 what? Hydrogen, right? Oxygen here connected to what? 2 what? Hydrogen. Oxygen connected to what? To 2 what? Hydrogen. What will be what? My remaining electron? Remaining what? Electron is what? 8 minus 4. Remember, 8 is what? Is total valence electron. 4 is what? Is the mass of electron I've used. 2 bonds. 2 bonds equals what? 1 electron. 2 bonds equals what? 1 what? Electron. So we're going to be what? We're going to be what? 4. So my remaining electron now is now 4. That is the mass of electron is remaining is what? Is 4. Now this is what I'm now going to move towards step 3. Step 3 states that you should do what? Give the side atom the octet electron before moving to what? The center what? Atom. Just understand? Which is very, very technical here. Please pay close attention. So if you look at it very well, hydrogen cannot form octet. Hydrogen cannot form octet. Hydrogen can only form duplets. And duplet means what? 2 electrons in the atomos shell. Just and so the two hydrogen are okay because they already have the numbers of electrons they want. Just so that is the remaining four electrons will move to the what center atom, which was oxygen here. Right there. So here going to be what 1, 2, 3, 4. Now, when you are giving them the octets, always put them in pairs. The electrons should always go in pairs. So you have 2, 2. Just making it what 4. So if you check it very well, hydrogen, this hydrogen is having what the duplet electron. This one is having what the duplet electron. While oxygen is having what the octet what electron. The octet what electron. How do I know it's going to have is having the octet electron? Because 2 bonds equals to what? 2 bonds equals to what? 4 electrons, right? 4 electrons, right? 2 bonds equals to what? 4 electrons. Now here we have 2 lone pairs. Right there. 2 lone pairs. And a lone pair contains 2 non-bonded pairs of electrons. So here we have 1, 2, 3, 4. 4 non-bonded electrons. Right there. So 4 plus 4 is what? Is 8. That is oxygen now have what? The octet what? Electron. Do you understand? Now the next one I want to look at is what? Is let's look at what? Let's look at what? NH3. Hi there. Look at what NH3. So let's calculate what the total valence electron. So now we can now start applying all the rules now. All the steps. So step 1. Now what is step 1? So we'll calculate the total valence electron. So my valence electron here go to what? 5 times 1. Hi there. How do I get 5? Nitrogen is in group. Nitrogen is in what? Group what? 5, right? Times 1 because the number of nitrogen here is 1. So it would be 5 times 1 plus hydrogen is what is in group 1. 1 times 3. Let me give me what? 5 plus 3 go to give me what? 8, right? So my total valence electron is what? Is 8. So it equals what? NH we call ammonia. The next thing we want to look at is what? Draw the skeleton by placing nitrogen at the center atom, while 3 hydrogen be the side atom. Do you understand? So going to be nitrogen here, hydrogen, and what? Hydrogen. Very important here. So if you check very well, this nitrogen is the center atom connected to 3 hydrogen here. Either with what? Single bondish. 1 to 3. Here we have 3 bonds. 1 bond contains electron, 2 electrons. Because here we have 3 bonds now, you got to be 6 electrons. Now out of the 8 electrons, I've used what? 6 electrons. So my remaining electrons is what? 8 minus 6, which is going to be what? 2, which is going to be what? 2 what? Electrons. 2 what? Electrons. I did 2 electrons. So now you say that the 2 electrons will go to what? To the center atom here because the 3 hydrogen are already okay. I did because they already have 1 bond here. So the 2 electrons will go to what? To the center atom here. You check very well, this is what the correct what label structure because nitrogen is having the octets. The 3 hydrogen have what duplet what electron. I they check very well. 3 bonds what is 6 electron. Here we have 1 lone pair because what 2 electron. 6 plus 2 is what is 8. Just now next one to look at now is what more complex structure here. Let's have more complex structure. CO3 2 minus. So this is to get complex here. So pay close attention. So now, first of all, let's calculate the valence electron VE. Right, the valence electron, we're going to be what? 4 times 1, right? Plus what? 6 times 3 plus 2. So 4 times 1 is what? Is 4 plus 6 times 3 is what? Is 18 plus 2. 4 plus 2. 4. Now, how do we get the 2? Because of this one here. Just 4 plus 18 plus 2 is going to be what? 24 valence electron. Just 24 what? Valence electron. Now, the next one to look at what is to calculate what is to what? Draw the skeleton. I draw the skeleton. And how do you draw the skeleton here? By placing carbon at the center what? Atom. As what? Center atom. Why the 3 oxygen will not be what? Side or atom. So, it's going to be carbon here. 1, 2, 3. So, for me now, I've used 6 electrons already because here we have 3 bonds, right? So remaining electron going to be what? 24 minus what? 6 going to give me what? 18 what? Electrons. 18 what? Electrons. So now, yeah, I'm going to ensure that the here was step 1, here was step 2, right? Let me to step 3. Step 3 says that what? ensure that the side atom have their octet electron. The side atom have their octet what electron. So if I should draw it here, can you see that? Now, oxygen must have octets. Oxygen must have octet. Oxygen must have octet, right? So if you look at this oxygen here, this oxygen already have one bond. Which is got two electrons. Right there. Now, normally this was supposed to be 8, but we already have 2. Now, how many electrons does it need to become the 8? Now need what? 6 more electrons, because 6 plus 2 is what is 8, which is called the octet group, octet electron. Do you understand? So it means that this guy needs 6. This guy what needs 6. This guy what needs 6. Do you understand? Now, if you guys should need 6, how many electrons are they going to use? 6 plus 6 plus 6 is what is 18. It means that my remaining 18 electrons will go here 6, 6, and 6. Just and so here we have 18 electrons now. Going to be 6, 6, and what? And 6. Just and so here we have 1, 2, 3, 4, 5, 6. Right there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Can you see that? Now I have exhausted all my electrons. I have what? I have exhausted all my electrons, because now the 3 oxygen here, the 3 oxygen here, I've got to what 6 is each. And each is what 6, mainly what total for 18. That is, I have exhausted all my 24 electrons. Just and I have no electron left. Now, since I've exhausted all my electrons, but if you check it out very well, when you are drawing Lewis structure, all atoms must have their octet electron. Just and so oxygen already have the octet, oxygen already have the octet, oxygen already have the octet. But carbon do not have the octet. The same atom do not have the octet. So are you going to live like this? The question is no. So how do you make carbon add octets? Now this is the number 1 step 4, which is what the last step. We say that if the state atom do not have the octet electron, move a sufficient non-body electron from the side atom to form a multiple bond with what the center atom. It means that, remember, 1 electron can form bond with another electron, right? So for it to form bond here, we have 2 electrons. Now, because we have a non-body electron here, a non-body 1 electron here, I get 2 non-body electrons. So what will happen here? You can either move down to this point here. I get. So when you move down to this point here, see what you go down. You have carbon. Right there. Now you have moved 1 to this operator to form a multiple bond here. Can you see that? To form a multiple bond. This is that. So now because you have moved 1 here, how many lone pairs do you have left? Here you have 2 lone pair. So that would be 1, 2, 3, 4. Can you see that? Now with this one with this, now all atoms now have the octet electron. Why? How is all atoms having the octet electron? Now let me explain to you here. It's because if you check it very well, this one have the octet, this guy have the octet, this guy have the octet, and carbon have the octet. Do you understand? So how do oxygen have the octet? Because here we have 1, 2, 3, 4, 4 electrons which are not bonding. Here we have 2 bonds. Remember, 1 bond equal how many electrons? 2 electrons, right? So the 2 bonds are going to be what? 4 electrons, making what? 8 of what? 8 to the electron here. Then this oxygen have the octet electron. Carbon on the other hand here, carbon have 4 bonds. Just and carbon have what? 4 bonds. Now because carbon have 4 bonds, what happened here? So is that what the octet electron? Because 4 bonds equals to what? 8 electrons, which means what? 4, which means what? 8 what? Electrons. Now, most of those here, remember, carbon is the average of 2 minus, right? So you cannot just leave like this. So the last step is to draw a square bracket here. Just that. So whenever you finish completely drawing the Lewis structure here, if it's what ion, is that negative or positive here? We must put it here. Put the square bracket and up. As easy as that. Just that. So that's going to be for what? For this one here. So now let's look at one more before we end class. SO3 2 minus. Let's look at what SO3 2 minus here. Let's look at what the total valence. So therefore, let's draw SO3 2 minus. Therefore, calculate the total valence electron, which is what VE. Total valence electron, which is V equals to what? 6 times 1 plus what? 6 times 3 plus 2, right? So 6 plus 18 plus 2 going to be what 20 what 6 20 what 6 valence what electron, right? Now next one to do here is that sulfur should be the center atom, just and then created to 3 oxygen here. So going to be x 1 2 3. Can you see that? So this is called the skeleton here. How many electrons have I used here? I've used 6 electrons because 3 bond, right? So 6 electrons, so going to be 26 minus 3 going to be what 20. Then I have 20 electrons left, right? Now because I have 20 electrons here, remember oxygen and oxygen must add the octet, just and must add what the octet electron. Now for them to have the octet electron, you have 6 6 6, you're going to be 18. They have 2 left, right? So it would be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18, right? So 6 6 6 is what is 18. How many electrons do I have left? 18 20 minus 18 is 2. Right there, because out of the 20 now, I've used what 18 6 6 6. How many do I have left? 2. That the 2 will now go to the center atom. So here we have this guy here. Can you see that? So if you checkmate there, where every atom have their own octet electron, 8 8 8. So for here is having 3 bond, right? Which 3 bond equals to 6 electron, then 2 here make it 8, right? So now this is not the correct level structure here. So but to complete here, you have to put a square bracket, just what 2 minus here. So this is what the correct what Lewis what structure. Now this is what the first part or the second part of this video here, of this series here. So in our next series, we have to solve more problem. You get. So see you in the next video.